for the students of Web 3.0 and blockchain. So we are curating content for them, and we also collaborate with different university, and we offer webinars. And even we both are part of CoinD6 Pathbreaker community. It's a community. It's a decentralized community, and they have this brand ambassador program. So we both are a part of that as well. So today we'll be talking about firstly Web 3.0. We'll discuss what Web 3.0 is. We'll discuss what the are the features of Web 3.0 and how it will revolutionize the whole internet. And then we'll discuss about blockchain. So blockchain is basically the backbone of Web 3.0. So let me share my screen and let's get started. So guys, is my screen visible? Sanket, screen is visible, right?
No, no, it's not visible. I can't see anyone else.
No, it's not.
You have the. I
Is
tried
it visible
making.
now?
No, no, I made you co-host. It's showing
Is
presentation,
it
but
visible now?
yes, yes, it's visible.
Let me do one thing.
No, I can't see the presentation.
Just a second. Let me try to share it again. Mm-hmm. Is it available now? Is it visible now? Now?
No, now it's gone. Now even the presentation screen is gone.
What about now?
No, no,
Okay.
anyone else? Can you guys see the screen is visible? Not yet.
Uh, Actually, it was showing some error. Let me do it again.
Hmm.
What about now?
Yeah, yeah, it's visible.
Is it fine
Okay.
now?
Yeah, yeah.
Okay. So, guys, these are the contents that we'll be talking about today. Firstly, we'll start with the evolution of web. That is with the beginning, and first we'll discuss about what was Web 1.0. So Web 1.0 was that era when the internet came, and we used to see websites with basic HTML templates, and basically the static websites, not the dynamic one. The websites where we can see the contact information such as fax, emails, and through which we can read some content, like the basic websites with the hyperlinks. And then came the Web 2.0. So in this era we saw dynamic websites, we saw web applications, and we even saw social networking, media sharing. We even saw some libraries such as JavaScript, which provided us with a rich user interface and the websites or the applications through which users can interact easily. So then came the Web 3.0, which is the current era. So in Web 2.0, we saw web applications such as Amazon, we saw Flipkart, we saw Netflix, Facebook. But in the Web 3.0, it is the decentralized era. This word came after when Meta announced, after when Facebook announced to rebranding its name to Meta, and when the metaverse popularity came. So Web 3.0 is we also call the decentralized era, where and so what happened is in Web 1.0 and 2.0, we saw the websites which were governed by a central authority, but in Web 3.0 it is not so. It is a decentralized era. There will be no central authority governing the whole internet. It will be decentralized, and we will be the only one responsible for our data. So Web 3.0 also overcomes issues such as transparencies. It boasts massive content that will be accessible to everyone, and it will Also in Web 2.0, we see like our data being hacked and our data being publicly available, and basically it's not safe. But in Web 3.0, the basic purpose of Web 3.0 is to overcome all these issues which we faced in Web 1.0 and 2.0. So this is a comparison between Web 1.0, 2.0, and 3.0. In Web 1.0, we saw the basic web pages, HTML. In 2.0, we saw social media, we saw content, high quality video camera, the global internet access. But in Web 3.0, it is an era of decentralized applications, or the DApps, where users can modify the data. It is an era of NFTs, crypto, and even the era of metaverse, where we'll be seeing virtual reality, augmented reality, and we can see technology such as blockchain, artificial intelligence, etc. So these are the characteristics of Web 3.0. Digital identities. It refers to our identities being digitally stored. It is an and trust basically. In Web 3.0, we use blockchain technology for trust. So because we are trusting on the technology that our data is secure, it depends upon the complete activity, and the micropayments part contain the cryptocurrencies through which we can make payments easily, even if we are making payments across the borders. So now coming to blockchain. So blockchain is basically the backbone of Web 3.0. When blockchain came into existence, Web 3.0 came. Web 3.0 is totally dependent upon this technology. So blockchain is just like a database, and or what we call a chain of blocks. But this and as we have seen, databases, they are governed by a central authority, but this database is not. It is a totally distributed and decentralized database where transactions are recorded, and a transaction can contain any kind of data. It can be a JSON format, it can be anything. So in short, blockchain is a database, but it's a distributed ledger. We call it a distributed ledger because ledger is kind of a table, and all the transactions are recorded in the ledger, and the ledger is publicly open to everyone. Everyone can see the transactions in the database because they are transparent, but they cannot see your data because data is encrypted. So these are the properties of the technology. It offers transparency because the data is stored on a ledger, and it is transparent. It is open to everyone. So transparency is maintained in the case. Also, one example for transparency is if you are sending payments from A to B, like if a person A is sending payment to B, and the person B says that he hasn't received the payment because there is no proof for the payment. But if the person is making payment on the blockchain, so transaction will be recorded on the ledger, and through that the person A can show to B that the payment is being made. So that's how a transparency is maintained. Immutable records. So the transactions stored on the blockchain, they are immutable, means they cannot be changed, they cannot be modified, and they cannot be reversed. Plus, it's a distributed ledger. We'll explain about distributed ledger and security part in the next slide. So, as we can see here, this is the block diagram of the blockchain. So, the first block in the blockchain is called Genesis block, and then comes block 2, block 3, and so on. So this is a chain, and and a block contains a data. It contains a previous hash, and it contains a hash value, or the current hash value of the block. So let's see how this chain is formed. So as we can see, the hash is 0234 here, and this is the same hash value is the previous hash of the block 2. So that's how a chain is formed, and all these blocks are connected to each other. So it is totally distributed across the whole world. Like anyone can access to the network. Anyone can see the transactions on the blockchain from any part of the world. And suppose if a hacker comes and try to tamper with the blockchain, so what will happen? the hash value of block 3. Suppose and he successfully is able to do that with their hash value. So if hash value of block 3 is changed, impossible to sum attacks such as and the data. So a data is stored on the block, and data is in the form of is encrypted, and it is encrypted using some certain cryptographic hashing algorithms such as SHA-1, Kechek 256. These are some cryptographic hashing algorithms which we use to encrypt the data, and it can be decrypted with the help of private and public keys. So in blockchain, there is a concept of asymptomatic cryptography. So in this concept, there are two types of keys. There are private keys and public keys. So what happens? So private keys are used to encrypt the data. So suppose if you are sending some data to a person, suppose there are two entities. There are A and B. A sending A and B both have their private and public keys. So public keys are open to all, and you have may have seen cryptocurrencies. You have a wallet addresses, and you get your private and public keys. So private keys should be the one that they can't be shared. They are just like passwords. Public key is the one they can be shared, and through public keys, no one can hack your data, or they can hack your wallet. But what happens is suppose you are sending some data, and you are sending data from A to B. So what will happen is if A receives the data from B, so A will use their private key to decrypt that data. So that's how this is the whole concept of asymptomatic cryptography, which is followed in the blockchain. So this is the architecture of the blockchain technology. So blockchain is an open financial ledger or the record where the transactions are authorized and authenticated. So before a transaction is stored on the blockchain, it is first authorized and authenticated. मतलब transaction का पहले पता लगाया जाता है कि whether it is legitimate or not, and it is designed in a decentralized. It is designed in such a way that it is a decentralized distributed network of millions of computers. So that's how centralized architecture look like. This is the architecture of or the internet of Web 1.0 and 2.0. But when it comes to the decentralized and distributed, that's how we see. So these dots are basically the computers or the miners which are sitting across the world, and that's how a network is made. And we can see this is a decentralized and distributed network. It and all these dots or all these computers are connected to each other. So that's how a network is formed, and that is the architecture of blockchain technology. So there are some key characteristics of blockchain. First is cryptography, and cryptography is a major part used in blockchain. The concept of asymptomatic cryptography is used, and cryptographic hashing algorithms are used to decrypt and encrypt the data. Immutability. So whenever a record or a transaction is stored, it cannot be modified, it cannot be deleted. And next comes the provenance. So whenever a transaction is stored on the blockchain, we can track from where we can track the origin of the transaction, from where the transaction was made, and from which address the transaction was made. Transparency. So whenever a data is stored or a transaction is recorded on the chain, it is open. So that's how the transparency thing works. So these were the key characteristics of blockchain technology. Now coming to how a transaction get into the blockchain. So suppose I'm minting a Bitcoin, and a transaction is requested from my end. So a block representing that transaction will be sent to every node, on the chain, or the nodes which are the part of the network. So the nodes will validate. Each node will get a puzzle or a nonce to solve. So the first node or the node which will have the highest computational power will mine the block, and that's how a block will be added to the chain. And in return, node will receive a reward. So that's how mining works in the proof of work consensus mechanism. And in return, miners and nodes receive the reward for solving that puzzle. And that after receiving the reward, the block will be added to the chain, and it will be distributed across the network. It will be updated on the ledger, and that's how when we can see the transaction. So this is how a real transaction look like on Etherscan. So Etherscan is the blockchain explorer of Ethereum. So here you can enter the transaction hash of any regular transaction, and you can see the transaction data on the Etherscan. Etherscan represents all the transactions which are being made on the Ethereum blockchain. So this is the transaction hash of the transaction. This shows the status. This shows the block, the height or the number of the block. This shows a timestamp and from which address from which address the transaction was made, and two. So this was made on on a smart contract, and this is the value sent with the transaction. Transaction fee is the fees paid to the miner or the node. Gas limit. This is the minimum gas limit. So on Ethereum, gas is basically the fees required to make the transaction happen, and from the gas fees only, the reward is paid to the miner. So gas fee is the fees required for making the transaction happen, and for maintenance of the network. It is similar to the concept is almost similar to the transactions when we made through our debit or credit cards. They charge a small fee. So gas is similar thing, but in gas it is almost negligible. So this is the gas used by the transaction, and this is the gas price, one GOE. So GOE is a unit of Ethereum. Ethereum has other units such as GOE, BE, and this is the nonce, the decrypted nonce. So nonce was the pattern which was solved by a node, or solved by the miners or the nodes while making this transaction happen. Next, come to the two types of blockchain. So there are two types of blockchain. One is public, other one is private. So the major difference between them is, like in public blockchain, it is an open network, anyone can participate. But in private, participants are pre-selected. In public blockchain, cryptocurrencies are required, and in private, no cryptocurrency is required. The decentralization rate is very high in public blockchain, whereas in private it is very low. And the throughput, that is the output. So output is very less in public, and it is very high in private, because in public blockchains such as Ethereum and Bitcoin, these are the biggest public blockchains. So there are a lot of participants on the network, and due to that network congestion, and due to high amount of participants on the network, the throughput is very less. And also this is the same for the energy consumption as well. And maybe you have heard, like for mining a Bitcoin, it requires energy equivalent to the energy used for in Argentina. Like it requires almost the energy used in Argentina for 1 hour. So we can see, like to mine a single Bitcoin, it requires a lot of amount of energy, and this is too because of a lot of participants in the network, and due to high network congestion. But in private, as participants are pre-selected, they are very less. Energy consumption is very low, and throughput is very high. So some example of private blockchain technology is Hyperledger, or the enterprise blockchain solutions such as Corda, uh, and Solana is also a private blockchain. It is the enterprise level blockchain. So now coming to the biggest public layer one blockchain, so Ethereum. So Ethereum is a platform powered by blockchain technology, and it has a native cryptocurrency known as Ether. So the biggest difference between Ethereum and Bitcoin is that Bitcoin and Ethereum both follow same consensus mechanism, but Ethereum allows us to build decentralized applications. It offers the features of building smart contracts, which Bitcoin does not offer. So Ethereum allows us to build decentralized application, means it allows to build applications on its own blockchain. It provides us the tools. It provides the functionality of building smart contracts. So these are the components. First one is the smart contracts. So smart contracts, what we call the backend part of the decentralized applications, and These are the type of code or the business logic we write on the top of the blockchain. And for writing smart contract, different languages are used. And for writing Ethereum based smart contracts, we use Solidity as its language. And Ethereum cryptocurrency is the native cryptocurrency of the Ethereum, which is used for maintaining the network. And uh, DApps are there, which are the decentralized applications. Then comes the EVM. So EVM is the Ethereum virtual machine on which the whole smart contracts and the Ethereum blockchain works. The whole architecture of Ethereum is dependent upon EVM. And then comes the consensus mechanism. So Ethereum uses proof of work consensus mechanism. So there are different consensus mechanism. So consensus basically means an agreement. What happens is, and as we see in the previous slides, like whenever transaction was made, so what happens is whenever there are a lot of nodes and miners. So but we know that only one and node or the miner will mine the block, and so all the nodes and miners comes to an agreement or a consensus that that particular person will mine the block. So there are different consensus mechanisms. So proof of work is one of the consensus mechanism. There are other as well, such as proof of stake. uh, Proof of stake is a very it's a very famous consensus mechanism which is used by Matic. Matic is a layer 2 solution. So now coming to the use cases. So DeFi, decentralized finance, is the biggest use case of blockchain, and DeFi is basically the trend or the shift from the traditional finance or the banking systems, insurance. So decentralized finance consists of the peer-to-peer finance, which is enabled by decentralized technology such as blockchain, and crypto is the part of DeFi. So crypto are all the fungible tokens. These are the digital assets or the currencies which are not governed by a central authority. And as we have seen, fiat currencies such as INR, USD. These are the currencies which are governed by a central authority. They are regulated by a central authority, but in the case of cryptocurrencies, it is not so. So fungible tokens means like fungibility means a lot. Like uh, uh, like there is not one Bitcoin. There are 21 million Bitcoin, and these Bitcoin can be traded with each other. So this is the whole concept of fungibility. But when it comes to non-fungible tokens or the NFTs, they are also a type of a crypto or a digital asset which are stored on the blockchain. And NFTs basically are stored in the form of a transaction on the blockchain in which data is stored or NFT metadata is stored. And NFT can be anything. It can be an image, it can be a video or a text. So the concept of non-fungible tokens and fungible tokens is that non-fungible tokens means unique. Like remember the cards, the WWE cards which we used to play in our childhood. So all these cards carry us a unique value. These cards were not similar to each other. So same the case with NFTs. They are unique and like they cannot be traded with each other. Like there can be only one NFT. So that is the main purpose, and NFTs also solves the purpose of ownership. So that's why we have those arts in the galleries. Now coming to medical and healthcare. So blockchain-based healthcare solutions are will enable faster and more efficient way for data management and supply chain tracking, because in traditional medical and healthcare system, data management is very poor. The data of patients are not maintained by hospitals properly, and medical supply chain tracking is very poor. We even don't know like from where those syringes or the medicines are coming from. So with the help of blockchain, we can overcome all these solutions. And next, coming to the global supply chain. So as we know, the whole global supply chain is very inefficient and poorly tracked. We even don't know from where the particular good is coming from. But as we know, on the blockchain, we can trace the origin of a particular transaction. So if we store products or the goods on the blockchain in the form of transactions, we can make our supply chain more efficient and properly tracked. Now coming to voting mechanism. So As we know, in a country like India, voting manipulation is a very big issue. So, and while voting, we don't know like our vote is being manipulated or not, because and we know that our vote can be tampered and can be changed with. But if we are making votes on the blockchain, and we know that votes are if votes are being stored in the form of transactions, they cannot be changed and they cannot be reversed. So that's how voting manipulation can overcome if we use blockchain technology. So coming to the opportunities in this whole Web 3.0 and blockchain technology era. So it is expected that by 2025 the market will grow to $40 trillion, which is huge. And day by day it is increasing. Many countries are slowly adopting the blockchain technology, and even Web 2.0 companies are now shifting to Web 3.0, such as Facebook. So there are many job opportunities in the blockchain technology. First is the blockchain developer. So there are two types of blockchain developer. One is the core or the software developer. So blockchain core developer is the one uh, who build the protocol, and other is the blockchain software developer who build the decentralized applications and the smart contracts. Next come the blockchain architect and blockchain designers. So the work of architect and blockchain designers is the same. They are the one who designs the whole architect of the decentralized applications, and they are the one who build the whole architect uh, of the um, of the whole network, and how to build a proper protocol, basically the blockchain protocol. And there are other blockchain front end developers as well. So what? So a blockchain front end developer is uh, like almost similar to a front end developer. Like they should be aware of front end libraries such as React and Angular, but they should understand how to integrate the front end with the smart contracts, that is using through Web3.js and Ether.js libraries. So these two libraries are JavaScript libraries which are used to connect front end with the backend. I mean the smart contracts part. Then comes the blockchain legal consultant. So while building cryptocurrencies, some legal consultants are allowed uh, because uh, 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 because something related to court and something related to tokenomics is required. So that's why there's need of blockchain legal consultants. And last comes the community managers and the blockchain content writers. So what I have seen personally as well, like when NFTs and crypto came, so the need of community managers and blockchain content writers it surged rapidly because there's a need of content writers and community managers who can handle the community very well, and and who can curate the content on the blockchain very well, because to do so uh, the basics it is required to understand the basics of the blockchain, and it is required that the individual should understand the technology very well from the depth as well, so that they can curate content and talk to the community about them. So that's why they are being paid very well as compared to traditional community managers and content writers. So these are the job opportunities, and there are a lot of job opportunities in the blockchain, which I didn't mention there. One is project manager, blockchain project manager, and it is not also necessary to become a blockchain developer if you want to get into blockchain. There are other various roles as well which you can try. So, guys, that was it. And now we have a small assignment for you. This assignment is basically the one where we teach you about Solidity. So, Solidity is the language used for building Ethereum smart contracts. And this small assignment will give you a basic overview of how a smart contract looks and how we can deploy this contract on the blockchain. Sanket, can you share me that?
Sure, let me just share it in the chat. Lakshit, I've shared it in the chat box.
Yeah, Sanket, yeah. Actually, I was having some net issues. So is the screen visible, right? Hello, hello.
Yes, it's visible.
Sanket, screen is visible.
Yes, yes,
Okay,
it's visible.
so guys, this is a small assignment. Firstly, it tells you about like what is Solidity. So Solidity is a high-level object-oriented language. It is inspired by JavaScript, C++, and Python. The syntax is almost very similar to JavaScript, but it is a statically typed language. And for building Solidity-based smart contracts, we use Remix. It is an Ethereum-based IDE, and in this assignment, we'll be building a sample smart contract, which is a calculator. So it will define the functions of a calculator such as addition, subtraction, division. So to make name it like calculate SOL. So SOL is the last word which shows that what type of language we are using. So here in this editor we can start building. So firstly, while writing a smart contract, we have to declare the version of Solidity. So here we are declaring the version, which is Pragma Solidity, and then we can declare the contract and the contract name, which is calculator. So that's how we'll declare a variable name uint result. So uint is basically an unsigned integer. It's a data type, and there are other data types such as bytes 32 string. And uint basically means an integer, but without a negative value. So as we have declare the declare the variable here, and now we can write the functions addition, subtraction. So here we'll write the function, and we'll enter we'll enter what type of what type of variable we are asking. Suppose we are asking two numbers here, so we'll define them as uint x and uint y, and this is the visibility modifier. So there are various visibility modifiers in Solidity. Public is the one, and we'll show x plus y. So that's how a function addition function is made, and we'll do the similar for other functions for other functions as well. Like you can try this assignment, and after we'll get to use this IDE, Remix IDE, for deploying the smart contract on the demo chain. So firstly we have to compile this Solidity file, and then we can deploy it through the address. So we are given 10 demo addresses which contains ethers. So ethers are given because while deploying it or while interacting with the smart contract, some gas fee is deducted, and the concept of gas fee I explained you earlier in the slide. So after doing this, after deploying it, here we'll get the confirmation that a transaction successfully the contract has been deployed and the transaction is being made on the chain. So after that, so what happens is, as I said, EVM is used Ethereum virtual machine. So that is same used in Solidity. So after deploying it, we get two things: we get bytecode and we get ABI. So ABI is application binary interface, which we use to connect, which we use with Web3.js library for connecting front end and for connecting front end and the smart contract. And after deploying successfully, we get a small interface here. So we get access to all the functions which we made. So in addition function, now I can add two numbers, and they should be positive numbers. So and after adding those, when I'll click this add, so I'll get the result here in this terminal. successfully. So that's how a smart contract is deployed, and these are the things in the contract. You'll read it, and you'll get to know like this is how basically you can deploy your own first environment, and let us know if you have any doubts. We'll be happy to help you out.
Guys, up to I think only 5 or 6 people are there. You don't have to use the chat box. You can just unmute and ask us if you have any doubts.
Yeah, like if you have any doubts, guys, you can ask us. We can take some Q&A here.
Hmm. And these doubts don't have to be related to coding or anything. You can talk about NFTs. You can talk about cryptocurrencies. Anything you feel like asking about.
Also, like
We
if you're not getting a relevant doubt in the mind right now, you can ask in our Discord server as well. Like
yeah.
we are pretty much
I'll
active
just
there, and we can respond your queries there as well.
I'll just share the Discord link. Jeet, please go ahead.
Yeah, so would like to recommend some resources or something like we
Yeah,
go
yeah,
through to
sure, sure.
start.
So resources are available on our Discord server only. Some starter resources and the beginner resources are there. And if you want to get into this, I can like a roadmap. We have also given a roadmap. Sanket, you can share the Medium channel here as well.
Yeah, yeah. So
So
on our Medium, there's this blog called 101 Guide to Becoming a Blockchain Developer. So what it does
so
is it just,
yeah.
gives you the roadmap, and then relevant resources are in the Discord server. Any problems you ever face, you can DM me or Lakshya.
Also, like if you are a beginner and if you want to start, I can give you a proper roadmap here. Like you can first start with the basics. Like firstly, you should have a good programming base. Actually, if you don't have that, you can start. You can have a good programming base by learning JavaScript, Python, C, C++, and DSA is also very important for getting into blockchain. And after that you can start with the basics. You can enhance your basics of the blockchain, such as what the technology is, the whole working, the understanding of consensus mechanisms, hashing algorithms, asymptomatic cryptography, and everything. And then you are pretty much good to go for development. So there are different blockchain languages, such as Solidity is there for writing Ethereum smart contracts. So Rust is there, Golang is there. So these are different languages which are available. So after that, you can get a hands-on experience, and yeah, you're pretty much good to go and to become a blockchain developer.
Thanks.
Also, okay, so I'll only ask a question from you all. So we were thinking of organizing a boot camp wherein we will teach you how to deploy your smart contracts. Or if you want to learn about cryptocurrencies, we'll teach you how to invest in decentralized finance. Or probably if you want to create your own NFT series, we'll do that as well. So any feedback as to what you feel could enhance the participation among your peers? If you guys are interested, only then we will try to facilitate something like this. And obviously, it will be free of cost. So do let us know. Just unmute yourself and let us know. Otherwise, we can just.
Yeah,
Sangeet, I guess, yeah, sure, sure, please go ahead.
I guess there are quite a few blockchain enthusiasts in our campus, and
Hmm.
many are willing to learn or start it out. I know many people are like me who are just starting out. So it would be great if there's a boot camp like this to actually have some hands-on experience on working out in that field.
Mhm. Okay, understood. And would you prefer this to be like an offline thing or like an online event is okay?
Both are okay for me, but offline would be more better.
Okay, okay,
Okay.
okay, understood. Okay, then since I feel that there are no questions, any questions you guys just can just
Jeet, you can
probably.
also stay in touch with us on our Discord server as well. Like if you have any doubts,
Hmm.
you want
Yeah,
resources, we'll be happy to help you out.
yeah.
Yeah, sure,
So
sure.
I think we can end this for now, right? Adarsh, what do you think?
Yeah, yeah, sure, I can.
Should we end this, Adarsh?
I guess Adarsh is, yeah, he's there, he's there.
Okay, no worries.
I guess we can end now.
Okay, cool. Thank you so much
Okay.
for having us.
If
It was really pleasant.
someone like, have any doubts, yeah, please share our Discord link. Like if someone is not available and if they want to, like if they have any doubts or they want resources, like please share our Discord server. And thank you so much for the session. It was great.
Yeah, awesome. Thank you. Bye bye.